Hi all, welcome back to MATLAB tutorial on Tooth Fulcrum. This session is on creating 2D plots. MATLAB provides a variety of functions for displaying data as 2D or 3D graphics. For 2D graphics, the basic command is plot. So let's see about the plot command in detail. To use the plot function in MATLAB, you should first make sure that the matrices or vectors you're trying to use are of equal dimensions. For example, if I wanted to plot a vector x, say x is equal to 3, 9, 27. Over time, my vector for time would also need to be a 1 cross 3 vector. So let's say t is equal to a 1 cross 3 vector, say 1, 2, 3. Let's create a plot into a new figure window. So use the command figure and then use the plot function. So use the plot function. So plot of t comma x. This gives a 2D plot which plots t over the x-axis and x over the y-axis. So this is the plot that we get when you give the command plot of t comma x. Now you could give a title to this plot. You can label your x-axis and y-axis. So to give a title to the plot, use the command title. So title is the plot of distance over time. Now you could label the x-axis. So use the command xlabel. So xlabel is time. On the x-axis we have the time. And you could label the y-axis. So ylabel. And on the y-axis we have distance. So now you can see the plot has got a title, plot of distance over time, and the x-axis is labeled as time and the y-axis is labeled as distance. Now let's try to plot a sine wave. For this we create a regularly spaced vector x from 0 to 2 pi using pi by 100 as the increment between elements. So let's say x is equal to 0. The step size, let's give it as pi by 100 and the limit is 2 pi. Now we'll calculate the sine for each value in x. So y is equal to sine of x. We'll open a new figure window. And onto this figure window, we will plot the sine wave. So we'll use the plot function, plot of x comma y. Let's label our axis. So we'll give a title. We'll label our x-axis. Also we will label our y. So y label. So we have plotted a sine wave and we have labeled the axis. We have given a title, x label and y label. So this is our plot of sine wave. You can plot the same variables with specified line style, color and marker. Let's say we want to plot the sine wave as red dashed line. For this, you can use the plot command. So plot x, what the data you want along the x-axis, and then specify the data that you want along the y-axis. Along with this, you can give the line specifications. So we want red dashed lines. So give the command R and give the dash command. So now you can see the plot has become a red dashed line. If you want a green color, you could give G. Suppose if you want a different pattern, suppose you want to get the plot as asterisk, you could give that as well. So now you could see the line is different now. It's green in color and it is a line plot of asterisk. So you could use the help plot command to see more about the line specifications. Now, to add plots to an existing figure, use the command hold. Let's open a new figure window. Now let's give this command once again, plot of x comma y. So this is our sine plot. Now let's say we are going to give one more plot. Say we want to plot a cosine wave. So before giving that, we will use the hold command. So hold on. Now let's say y2 is equal to, we want a cosine function. So cos of x. We'll use the plot command. So plot of, so this plot will be again onto the same window, figure window. So plot of x comma y2. Let's give some line specification so that you can differentiate between the two plots. So let's give this plot in colon. So you could see the two plots here, sine wave as well as the cosine wave. Now, to distinguish between these two plots, we could make use of a legend. So, the command is legend and then specify your plots. So, first plot is sine. So, you could give it as sine, then comma, our second plot is cosine. So the legend is differentiating the two plots. This blue line is showing a sine wave and the red dotted line is that of a cosine wave. Use hold of command to stop plotting on top of the existing figure. So hold off. Now let's see how to create a subplot. When you create an array of plots in the same figure, each of these plots is called a subplot. So let's create a subplot of one row and two columns, and to the first row first column we'll plot a sine wave and to the first row second column we'll plot our cosine wave. So how do we do that? Use the function subplot. The first entity specifies the row number. The second specifies the column number. So we are going to create a subplot of one row and two column. Then you have to specify the location where you are going to plot. So we are going to plot the sine wave first, and the sine wave should come in the first row first column part. So specify 1. So we have created a subplot of one row, two columns, and we are going to give the plot into the first part. So onto the first part, we will plot our sine wave. So x comma y. So you can see this first part, you got a sine wave. So we have labeled our axis as well. Now we will plot onto the second part. So again, subplot one row, two columns, and to the second part, you are going to plot the cosine wave. Now here we will plot our cosine wave. So plot of x comma y2. y2 is having the cosine function. Let's give title. So you could see your two plots, sine and cosine. Now let's create a line plot from a matrix. So let's say now y is equal to, let's create a magic matrix of say 4 cross 4. Let's use a new figure window. And now let's plot this. So use the plot function, say plot of y. So this creates a 2D line plot of y and plots each matrix column as a separate line. Now let's make use of markers. Let's display markers at specific data points. Let's create a line plot and display markers at every fifth data point by specifying a marker symbol and setting the marker indices property as name value pair. So let's say x is equal to, we'll make use of linearly spaced vector ranging from 0 to 10. And let's say y is equal to sine of x. So let's use the plot command, plot of x comma y. Now we'll start specifying the specifications for the markers. So let's give the markers as hyphen O. Now we'll specify the marker indices. So marker indices. Now we have to specify the marker indices value. So we want at every fifth point. So 1, 5, 2, length of y. Length of y. So you could see the markers here at every fifth data point. You could modify your lines after creation. That is, we have given a plot of say x comma y. We have this plot with us. You know, this is a plot of our sine wave. So we have this plot of sine wave. Now suppose after plotting this, you want to change the properties of this. For example, you want to modify the width of this line. Let's see how to do that. So for this, we'll make use of a handle. So say p is equal to plot of x comma y. So p is the handle to our plot, and using this handle, you can change the properties or access the properties of the plot. So you could see the properties of the plots here. Color, line style, line width, etc. Now say the default line width is 0.5 and now we are going to modify it to say we'll increase the thickness. So let's modify it to a value of 2. So for this, use the handle and the dot operator. So p dot, use the property name as such. So line width equal to, you can give the new modified value. So now you could see the line width has increased. So as you have changed the line width, you could access any other properties as well. So this is few commands in MATLAB to handle a 2D line plot. Thank you so much for watching. Please do like, share, comment and subscribe. And please don't forget to tap the bell icon. You'll get notified whenever we upload a new videos. Thank you.